Hello and welcome to this session on modern event-driven workloads with Knative. My name is Roland Huss. I'm a software engineer working at Red Hat. I'm the OpenShift serverless architect and also a member of the Knative community and part of the technical oversight committee. So before we dive into the details of Knative and how it can help you to run your Java applications, let's talk briefly around serverless. What is serverless? And like this guy, we have probably some questions around the definition of serverless. And if you ask 10 different peoples about what serverless is, you probably get 10 different answers. And here's ours. So serverless itself is a deployment model. It's really about how you can run your applications without knowing about the underlying infrastructure. So you don't have any server management required. One of the benefits of this model that this allows you for a billing model which only accounts for the traffic and for the usage of your applications, which means that if your application is not used at all, I don't hope this is the case, but if this is the case, then you don't have to pay anything. So there's a reduced risk there. But also if your application is very popular and you want to serve many users in parallel, then you also benefit from the automatic scaling upwards, which allows you to run your applications in parallel. So all these kind of things are kind of a key concept of a serverless platform. Beside this, there's also a deployment format packaging, which allows you to bring your application to the platform. This could be either something like a custom packaging format, like a tar archive, which contains your application, like for AWS Lambda, or it could be a standard like a container image. So this is a deployment model, but then you probably already heard about functions as service or FaaS or functions in general. And this is considered more to be a programming model which sits on top of serverless. This functions as service mandates that your applications are composed out of fine-grained functions that adhere to a certain function signature and get easily deployed on a serverless platform. So one typical use case for FaaS-based applications is this kind of glue code that you often see if you want to connect different servers together, enrich the data that you get from one service with your own custom business logic, and then perform a certain small limited action. And together with many of these functions, you create your applications. And AWS Lambda made popular this kind of model. In this talk, we are talking only about the deployment model, about serverless. And Knative actually is a platform that allows you to run your application in a serverless way. It does not tell you anything about how you should program your application, but it tells you how you can operate it with these benefits of automatic scaling and others. Okay, now that we have set the context clear, let's talk about Knative. Knative itself is a Kubernetes-based platform. So this I haven't told you yet. So it's a platform for serverless applications on top of Kubernetes. So it requires some Kubernetes-based platform underneath, and it allows you to deploy and manage your serverless workloads. And Knative itself is composed out of two components. One is called Knative Serving, and the other one is called Knative Eventing. Serving is really about this auto-scaling feature. It's a request-driven model, so you need a HTTP request coming in from the outside. So scaling is typically based really only on traffic, so on consumption. And in this case, Knative itself only deals with HTTP as a protocol. And it allows you to scale down, even down to 0, and up based on the traffic. On the other side is, of course, is where does this traffic come from? Of course, this can come from your users, your just web interactions, but also it's very suitable for building up an event-driven application, which allows you to react from outcoming events. That these events can be coming from different sources, and Knative allows you to read or consume events from these sources and then route them to your Knative services to process them. Before we go into more details of both of those components, just some background information. Knative itself started as an open source project around mid-2018. It was initiated by Google, and it's a community-driven project with a lot of vendor support. So there are many vendors which are actually actively supporting Knative. Google, Red Hat, IBM, VMware, Triggermesh, and many, many more. And there are also, of course, individual contributors. It's a very open project. Even if it's not part of an open foundation, it still has a lot of similarity with the Kubernetes process, which means that there are several committees like the Technical Oversight Committee, the Steering Committee, that are all elected. And only the Trademark Committee, which really deals about the brand and the trademark, is kind of vendor-backed, and there are several seats for the major contributors of the project. The releases happen frequently and periodically every 6 weeks. At the moment we are at release 0.23. 1.0, I think this is important for you as well, is targeted for the mid towards the end of the year. But even if it's still kind of an 0. something release, there are products out there which are GA and which you can use with the full support. Okay, so now you get have an idea a little bit about the structure of Knative, but before we tell you how you can use Knative, here are some pointers how you can install it yourself or try out one of the public offerings. First of all, you can install Knative on any Kubernetes cluster, whether it's kind of a small one like Minikube or like on Kind or on Docker Desktop. Or you can install it, of course, on a Kubernetes cluster which runs in the cloud. How you can do this, you can find all this information on the Knative website. Then there are public offerings that you can directly use. Some of the more prominent ones are IBM Cloud Code Engine and Google Cloud Run. So these are managed Knative service, Knative installations. So you just go in and then you can deploy your applications as a Knative service. And then you have also Red Hat OpenShift Serverless. This is the product that I'm working on. This is about how you can run Knative on top of OpenShift. So if you have an OpenShift installation, you know OpenShift is the enterprise distribution of Kubernetes by Red Hat, then you can just with one click install Knative on top of this. It's called OpenShift Serverless in that context of OpenShift. And then use all of the Knative features, including eventing, which are often not part of the public offerings. Okay, now we have set the context. Now let's see, what is this Knative serving? So let's start with serving. Serving is really all about scaling, auto-scaling, about routing, and about creating revisions for your application changes. What does this mean? First of all, it's important to know that like everything on Kubernetes, on Knative, which is based on top of Kubernetes, I already mentioned that, is based on Kubernetes resource definitions, CRDs. So CRDs are the extension model of Kubernetes, how you can add your own types to Kubernetes and let Kubernetes manage those types. And we see most of the Knative custom resources later on. It's about demand-based auto-scaling. I mentioned that it's really based on the traffic that is coming in, and it's really about concurrent traffic. So Knative really measures how many requests are in flight in parallel, and depending on that number, it either scales up. For example, if it's more than a configurable target, then it will scale up your applications to several pods running in parallel. Or if there are 0 requests coming in, then it also scales down your application to 0 pods. It allows you to separate your code and the configuration. And it's important to note that Knative itself is suitable only at the moment for stateless applications, which means you cannot hold state in memory. Of course, you can put out the state into some external cache or database, which you need to recreate after each request. So typically a client probably would send a cookie and you will fetch up your session again. Then there are other restrictions like a single port, and of course there's no persistent volumes. So there are some parts of the usual Kubernetes deployment that has been stripped off. But in reality, I think it shouldn't really matter much. Finally, there's a lot of ways how you can configure your routing. you can split up your traffic amongst different versions of your application so that you can implement certain rollout strategies like canary releases or blue-green deployments. If you look at the custom resources, that looks like this, the graph. So the first, on the highest level, is the service. The service itself is really typically the user-facing object. So this is the CRD that you create on your own if you want to deploy a service. You can do this with regular YAML files like you do with other Kubernetes resources. And if you create such a service, then some other objects are created on behalf of, like a configuration and a route. The configuration actually is kind of the current configuration of the application or the head of a history of revisions. So every time you change the configuration object, then a revision gets created for you. And in this scenario, if you change the service, the associated configuration, which is a one-to-one association, gets updated, and on behalf of that, a new revision gets created. For example, if you update the image within the configuration, then you get also a new revision. And this is where the route comes into play, that can route the traffic to different revisions. And now in this picture, let's assume that the top level revision here with the 10% is something like your newer image that you just wanted to roll out. And the other one is your currently running version of your application. And so you can flexibly define a route that says, okay, let's route 10% of the traffic to that revision and 90% to the other one. But the route itself is also can be configured via the service. So the service declaration also contains the information for a route and for a configuration. As mentioned, all the objects below the service are typically managed for you automatically, but you can of course create also your own routes, so you can have multiple routes pointing to different revisions. Then another very important characteristic of Knative services are that they are very simple. So let's look at the example here. So what we see here on the left-hand side is really a deployment, a standard Kubernetes deployment. And you see that there's kind of a lot of boilerplate in there, which you need to understand. And of course, because it's YAML or JSON, you can also make easily mistakes in writing this down. And of course, a deployment is not enough if you want to expose your application to the outside. So in this case, we want to deploy an image, which is called random number, or a service, which is called random number. But to expose it, you also need a Kubernetes service and a Knative service. By the way, I just forgot to mention that although the Knative service is also called service, it's not the same like the Kubernetes service. So this often leads to some confusion, so that they are different in the respect of the API version. You see here at top serving Knative.dev/v1, which distinguish this service from the Kubernetes service. Yeah, the choice might be not the best, but actually it is like this. So you create a service like this. You can omit the replicas because the number of replicas are fully managed by Knative itself. And you can omit also the label selector for your pods, plus some other stuff. So it's really kind of a condensed version of a deployment. And the big benefit is if you deploy the service, then the controller which monitors these resources is really creating implicitly for you Kubernetes objects, namely a deployment, a service, and an ingress object, or if you're an OpenShift, a route object. So all you need to do now to create everything you need for a simple web application is really to create the service and throw it over to Knative. And I think it's now time for a short demo. Let me switch over. So what I'm demoing here is this kind of service. So here I have a JAX RS application, which we will build as Quarkus based. So we are using Quarkus for running this JAX RS application. Quarkus itself, Quarkus is a very opinionated framework which is optimized for usage within the cloud and on Kubernetes clusters. And the benefit, especially for Knative, is that it really has a very quick startup. And this auto-scaling feature means that you scale a lot up and down, and therefore the startup behavior is very important for Knative. So what we have here now is a simple application. So we're exposing on the root context here, we're exposing a random number. So we wait even for some seconds if a certain environment variable is set. And then we expose something like a general user ID, a random number, which is based on Java auto random. It's not shown here, but actually you can, it's very easy. And then a version number, which indicates the version of the application. So this is all I have for the basic, for this demo application. And now let's create that. So actually what we did, of course, we compiled that, we put it into an image, and then we pushed it to Docker Hub. So, to create a Knative service image, you can use descriptors, as I mentioned before, but you can also use a CLI. So Knative itself comes with a CLI, it's called KN. This is a usual CLI as you know them, like group control. So you have what you want to do, and yeah, so you have the object and the verb, service create, and you give the service a name, and then we point it to the image. And this is all you need for creating a Knative service. So what we're doing now here is we're handing it over. The CLI also will wait until the service is ready to serve. And now you see at the top here, we have a watch here on the pods that are running at the cluster. And now I can just use curl to, just use curl to run on the URL that is exposed. So what I have here running in the background is an OpenShift cluster in the cloud, and this is my development cluster, and it exposes here the URL. And if you see, you get back the ID, the random number, and the version here as well. So random number is of course, oh sorry, this was the curl. Random number is of course random. Okay, what I can do now with this service, I can of course list them, but I can also make an update on this. Now let's check here, KService update. So what I'm doing here is now I'm updating certain, so we have tons of options that you can configure for Knative service. I'm showing you here some of them. So first of all, you can configure the concurrency limit. This is by default is 100. What does this limit actually means? So the limit tells Knative how many parallel requests can handle per pod. So if you get more requests that a pod can handle, then the number of pods gets scaled up. In this case, we have a limit of 10. As I'm setting a limit of 10, which means if I have more than 10 parallel requests to be processed, then Knative will scale up your deployment to have more pods. Then I'm also configuring the autoscale window, which means the autoscale window actually defines the granularity of your autoscaling mechanism. By default, it's 60 seconds. So after 60 seconds, when no traffic comes in, then it will scale down to 0. So this is actually happening here. You see here that the pod is going down because I'm just talking too much here. And then you can set, of course, environment variables. And I'm setting here one, which is tell our service to wait 1 second so that I can simulate some work in the web service so that we can get really concurrent requests. Otherwise, if every request immediately returns, then it's hard to see that. Okay, let's make the update here. You see here in the top something is happening. Of course, still the old one is terminating. The new one is coming up. And we can curl it again and we see that, of course, we don't see much here. But what you can look now, look now at the revisions. And as you can see, sorry, it's also okay in the revision list. Sorry for that. So as you can see, the first one was revision 1, and then we have revision 2 here. And this gets all the traffic. And by default, if you change something in the service, then it always, the route will follow your latest revision here. And I can now give it also a tag. So I can service update random. Give the tag number 2 a name v1. Check that. You see you have v1. And what we can do now, we can now make an update of our application here. And let's do that. Get service update. random minus image. So what we are doing here now, we're setting a new image, which is version 2, and we create then a traffic split. So we are doing here splitting, say, okay, for this new version that we are just about to deploy, we want to have 50% of the traffic. And we want to have 50% of the traffic for the old version, which is tagged as V1. And we are setting back the auto-scale window to 60 seconds so that we don't have this many auto-scale up and down stuff here for the new version. Actually, the old version still has 6 seconds. So we see here now that it's starting. And we can now again curl on the URL. And we will see, okay, now the other one is starting as well. So we see 1.0, 2.0. So we get roughly a 50-50% distribution. Over the long run, it will be perfect. So yeah, okay, it's nearly perfect already. Okay, and then we of course can finally check what happened if we are making many requests in parallel. And of course, these both get distributed over all the other ones. And as you will see now, because I'm using here Hey, which is a simple CLI load test tool, we are running 300 parallel requests against this one. And as you can see, many more containers are created just to find out these, just to serve the traffic and you also see that these containers are starting in parallel simultaneously, not so that one pod starts after the other one. So there's kind of a burst mode which allows to start up many pods at the same time if Knative detects that there's really a burst in the traffic. It's kind of a spike. And of course you can here look into the logs. Let's see. And here you see that we have Quarkus running. And as mentioned, because of this quick scaling stuff here, it's important that it starts up quickly and you know all that Quarkus is really a champion when it comes to startup times. Okay, this is about the demo. So now let's go back to eventing now. So we have seen mostly everything about serving. Now let's go quickly over eventing. So first of all, what is eventing? It's all about the universal subscription delivery of cloud events. What are cloud events? So cloud events is our CNCF standard, and it actually defines an envelope for your events. So it defines headers, certain fixed of the keys for the headers, how the payload look like, how the transport look like for cloud events. So it's really kind of a standard for transporting events within the cloud. And how are these events are really transmitted from one side to the other one? This is done via channels. This is a concept in Knative Eventing, again described and declared with a custom resource. The channels are backed by either, in a simple case, by an in-memory implementation, which just receives the event in memory in the data plane and then pushes it on to the destination. Or for more production-grade setups, you can use a system like Apache Kafka, full-blown messaging system, which with all the benefits that Kafka comes with. Knative Eventing allows you a flexible routing between source and sink. So there are two concepts. One is that of a source, which is an adapter for integrating third-party systems. And the idea this adapter is really, the main task of this adapter is to transform custom events into a cloud event format. So it really picks up, like, for example, like notification from S3 and then transforms it into a cloud event. Then these events are pushed onto a sink. So the sink are the consumers of these events. And one of the most prominent consumer, of course, is a Knative service that we just have seen. Let's talk quickly about event sources. So our event source is really, as mentioned, for integrating third-party systems with Knative, like, as I already mentioned, S3 buckets, like GitHub webhooks or other event originating systems. And it's also, as mentioned, more often an adapter than an original event source. So of course, an event source in Knative can also be the real source of the event, like, but like the ping source, which we see in a second. Ping source just sends out periodically a constant event every minute or so. But more often, it's really this kind of adapter. Again, an event source is mostly declared by an own custom resource, so every source has its own type of a custom resource. This custom resource is then watched and reconciled on by an operator. Sources can be push or pull based, so the adapter could either be notified from the outside or periodically polls the external system to check whether there needs to be an event sent to somebody else. And as mentioned, converting custom events is one of the main tasks of a source. Here are the list, non-comprehensive list of sources that is available for Knative. So there are 4 sources that come out of the box with Knative. One of the ping source, which emits static cloud events periodically. So you provide a cron type expression and then you get a constant data sent to your sink every such a time. Then you have the API server source, which transforms the events that are emitted by the Kubernetes API server into a cloud event format. So for example, that you get an event every time a pod gets deleted or created, whatever. So you can react on those events. Then there are more general purpose sources like a sync binding. So a sync binding allows you to connect an arbitrary deployment or anything which holds a pod specification. And this works that way that every time you connect a sync to this sync binding source, then the deployment or this so-called pod specable that it is pointed to gets an environment variable injected so that it knows how to reach out to the sync. So if your application is ready for that and just checks for this environment variable, which is called k_sync, then it can just push events to this URL. The container source is a little bit an abstraction layer higher, which just combines the sync binding and the deployment description for your container is also part of this CRD. So the container source contains the sync binding plus, for example, the name of the image, and then also controls the full life cycle of this deployment, whereas the sync binding really works with the existing deployment. Then there are also sources that are contributed by the community, which is a GitHub source that listens on GitHub webhooks, Kafka source that reacts on messages that are in a topic of a Kafka cluster. And then one very interesting one, which is about camelets. So you probably have heard about Apache Camel, which is an AI framework that allows you to connect to different external systems. And camelets allow you to leverage all these 100, 200 plus components from Camel directly with as a Knative source. Okay, now we know what source is. Now let's quickly talk about how you can connect a source to a sink. First of all, you can make a direct connection, which means you link together the source and the sink with a field in the source. So the sink field is always present in every source. And this is the simplest way, but of course it has many drawbacks. So you can have only one sink, then you have no back pressure support, and then there's no queuing when the sink is unavailable. And you have no filtering, so the sink actually gets every event that the source emits. Then one level higher, you can also connect to a service with channel and subscription, which means you create a channel. As mentioned, channel is also a CRD, and you can create other objects called subscriptions that are connect the sink to the channel, and you put the channel coordinates directly into the sink field of the source. Of course, benefit is that you can have multiple consumers for the same event. You can also have more advanced setups, like the sink can also, the subscription can also provide us a reply channel, so that any reply by the sink, which is the HTTP response from the request it gets routed to another channel. And again, you have multiple channels, so you can use in-memory or Kafka. The drawback is, of course, that you have to set up a lot of stuff manually. There's no filtering, and servers get all events. And finally, and this is I would say the most popular setup and the most advanced setup, and also more simple setup to use, is that you leverage a broker. A broker is an instance that is running in the cluster as well. You can connect the source to a broker, and the broker gets then all events, and it's the broker's duty to route these events to different sinks. And the sink can express its interest for certain events by the means of a trigger. This is similar to a subscription. but it can also contain a filter which says, okay, the sink then only receives the events from this with this kind of type, for example. And also everything what the sink returns at the HTTP response gets fed back to the broker. So this is very flexible and used in many setups. Yeah, you can filter on events, and you can, and as mentioned, the trigger can also route the produced events back to the broker. Okay, this was really kind of a round trip through Knative. There's more to talk about eventing and serving, but actually the best thing is just try it out. It's really very simple to set up and to try out Knative yourself. In summary, Knative Serving is all about simplifying your deployments, about auto-scaling, and about traffic splitting, that you can create custom rollout and rollback scenarios. Eventing is really the perfect fit for event-driven applications, EDA applications, which means that you can connect services together, you can retrieve external events, you can retrieve internal events, and this is really for this, and you can create a FaaS on top of these building blocks. So as mentioned, Knative itself doesn't provide any function or functional service functionality, but it are really perfectly suited for creating, for being a building block for those services. But of course you can Knative use on your own as well, for sure. And yeah, that's it for now. So if you have more interest, so you can have a look at this book. This is for free, so you can download this. Has more details, and also kind of a workshop so that you can try out things. And if you even have more interest about Kubernetes itself, I think this might be also interest for you. There's a free book, again sponsored by Red Hat, which you can download. It's all about Kubernetes patterns, so it's not so the Knative is also mentioned within this book, but actually there are many more patterns that you can use here. And with that, I wish you a nice conference, a REST conference, and yeah, hope to see you soon live again. Thanks a lot. Bye bye.